Hello, welcome. Chapter 9. We got polar coordinates today. And in a very basic definition I wrote here, is just using distances and angles to describe the locations. Okay. Angles will be in both radians and degrees, and then, of course, distance will be distance. Here's what it would look like. Now, I have three definitions down here that will be important for us. Origin, we call it the pole. Usually with this big L right here. And the polar axis is this item right here. Polar axis. Initial ray of the pole. Now, normally this would be kind of like where 0 degrees would be at if we were graphing this, right? So this should be horizontal. I'm just not a good artist. And then the polar coordinates is location from point P. So right here would be P. R comma theta, r meaning the distance traveled from your pole to this value, and then theta is degree right here. So this is a couple quick examples where you're typically not going to graph it this way without the proper grid, but we will just to show you how it might look. So let's draw the polar axis. We have pi over 2 up here, and then it's -1. So we're actually going to be going backwards, right? So because if positive 1's down here, we're actually going to be going down there. So straight backwards. There you go. -1. Pi over 2. 2.5 common 240 degrees. 240 would be somewhere right there with the polar axis right there. And that's your theta, 240. I should label this as well. Pi over 2. And how far do we go? About 2.5. We'll call that 2.5. When we have our grid, it'll be much easier to label what that value is. That's E, that's D. -5 pi over 6. I don't know why I drew that. I don't need a whole plane. I just want polar axis. And then -5 pi over 6 would be somewhere right there. And there we go. I much prefer graphing on this plane. It's much easier to work with. So the center here would be if R was 0, 1, 2, 3, 4. So first we got 1.5, 7 pi over 6. 7 pi over 6 is over here, right? So at 1.5, this is 1, somewhere in between, right there. And then we got -2, -135. -135, we're going backwards over here. So -135 would be right here. And it's -2. So if -135 is right here, it's going the opposite direction. So it'll be right here. 1, 2, right here. There you have it. Next, find 3 additional pairs of polar coordinates that name the given point. And they need to be between -360 and 360 degrees, or -2 pi and 2 pi. Because if you think about it, so if I keep going around in a circle, I can keep hitting the same point, right? So one of the easy ones we can rattle off is if I subtract 360 from 240, which gets me -120 degrees. That's the easy one, right? Now, keep in mind, I gave you these instructions right here. So I can't keep subtracting 360 because I will get something not in my range. But what I can do, keep in mind, 240 is down here. right, to get to 5, 240 right here, there's multiple ways, right? So if I was going the opposite direction right here, and if I had a negative 5, I can also get that. So what is that in degrees right there? How can we find what that is in degrees? Well, if we subtract 180 from 240, we will get what this value is right here. So that would be 60 degrees and negative 5. Now, if I subtract 360 again, I'll get to the same value, so it'll be negative 5, comma, negative 300 degrees. Cool. Now this one, let's do the easy one right away. Subtract 2 pi. So we have right away 2 pi, comma, negative 11 pi over 6. Now, once again, instead of adding or subtracting 180 to this value to get the negative values, it's going to be the pi equivalent, which is pi. So if I add pi to that, I will get negative 2 comma 7 pi over 6. And then also, if I subtract 2 pi from 7 pi over 6, get negative 2 comma negative 5 pi over 6. All right, so I need to make a little makeshift polar coordinates here. So we have r equal to 2. We won't need to graph it. So where is r equal to 2? This is 1, and this is 2. I'm just going to draw a circle around 2. Because that's everywhere r is equal to 2 at. So it'll just be a basic circle right there. There's your graph r equal to 2. Next, 2 pi over 3. Now 2 pi over 3, of course, is about right there, correct? Yes. But it is also, if it's negative, it could go down there. So I have to graph both possibilities. So just a line that goes all the way through, like so. Finally, here's the polar distance formula. Go ahead and jot that down. This is for if we have 2 points, P1, we'll call it R1, theta 1, and P2, R2, theta 2. We got a little word problem for us. So we have 2 points we need to draw. Which would be kind of hard to draw, but I'll estimate a little bit. So 8, 150. So it'll be all the way out. I'll probably move it over a little more. Call it right there. And 365. So about right there. And we need to find that distance right there. So as you're drawing of it, R1 is 8. 8 squared plus 3 squared minus 2 times 8 times 3 times cosine of 65 minus 150, square root all that. Make sure your calculator is in degree mode. Yeah. And you should get about 8.30 miles if you put in your calculator. Okay. I appreciate you watching. We'll see you later. Bye-bye now.